स्टार्ट किया आपने? Yeah, it's live now.
Yeah, okay. Okay, so hello children, a very good evening, and I'm really very sorry for getting late. So thank you so much for waiting. Like now we are going to start, and in today's class we are going to solve the last 10 last years of PYQs of KCET from the chapter Chemical Kinetics. Okay, so now we will start. So let me just check who all are on live, and a very good evening to all of you, and I hope that you haven't moved away. Okay, so okay, I think now I am live. Okay, fine. Yes, just a minute. Just give me 1 second. Okay, so are you ready? So now just let us have a quick discussion, like how much you have actually prepared for your exam. So hi Ishan, hi Sajina, hi Karthik. This chapter is there for quarterly. Okay Ishan, so don't worry, you can revise today very easily, all the concepts and everything. Yes. Okay, so students, before starting the session, you all need to share the link of this session with your at least 5 friends. Okay, so now we have 8 students live here, right? So 8, if you share it, at least 3 students also, we need to have at least 20-25 students live, so that there will be a much interaction, a much healthy classroom environment. You can see where your competitors are standing, whether they are able to answer or not. So that is why quickly just share this video with 3 of your friends, and then let's start this video. Okay, okay, thank you so much everyone for joining. And yes, the live count is increased now. And yes, now the thing is, in the last class we have discussed about chemical kinetics. I have taught you some concepts, and you are really understood the concept. So based on that, today we will solve some questions also, right? So only learning concepts will not help. We have to actually apply that concepts in our question solving. So those is this quiz, Aryan, it is quiz plus question, concept plus question solving. So please don't worry, we will be talking about concepts as well. Okay, yes. So now tell me, how many of you have prepared this chapter? You are very confident about this chapter, and you know all the concepts. You are done with this chapter. If you are done, then tell me. Yes, come quickly tell me in the comment section if this chapter, like just rate it in between, like done, half done, not started, done, half done, not started. So just tell me in the comment section that what is the status of this chapter in your preparation right now. Yes, hear me ma'am, I am done. Okay, Satish is saying he has done this chapter. That is really done. 75% done. Pranavi, very good. Sajina, half done. Yes, yes Soumya, definitely we are going to do that. Karthik is saying not done. Please don't worry, in today's class this chapter will be done for you, because we are going to practice, we are going to solve a lot of questions, and also I'll be explaining you the concepts, right? Okay, so children, are you ready for the first question? So first I will explain the concept, okay, then there will be the question. So you need to answer, using that concept you have to answer the question. Okay, so let's start with the first question. The question is from the topic rate law. In the last class I have told you what is rate law. Rate law is an expression. So what is rate law? First let's understand quickly what is rate law. So rate law is an expression, okay, rate law is an expression which relates between what? It gives the relation between rate and concentration. Okay, gives the relation between rate and concentration. Now suppose I have a reaction like this. A plus B gives you C. Then what is rate equal to? Rate is equal to K into or A to the power of X, B to the power of Y. Right? This is my rate law. Now ma'am, what is X here? What is Y here? X is the order with respect to A. Similarly, Y is the order with respect to B. Okay. So now the question is, yeah, now students, now let's see the question. The rate of a gaseous reaction in the expression is KAB square. So for a particular reaction, the rate given to us is KAB B square. Okay, this is the rate law for the given reaction. If the volume of the vessel is reduced to if the volume of the vessel is reduced to 1/2 of the volume, the reaction rate as original rate is. Okay, now see what happens. What is the square bracket represents? What can anyone tell me what is the square bracket in the formula represents? What is square bracket? Tell me. Yes, students, I'll go very slow. I'll explain each and every question. So please, if you have already understood, then listen once again for revision. Those who don't know, please listen carefully. Okay. So the square bracket is nothing but concentration, right? It is concentration. Concentration is actually it is molarity. We all have studied the formula of molarity, right? What is molarity? Molarity is equal to number of moles by volume. Now, in the question, it is saying that the volume is reduced, okay? So, now just see, molarity and volume is inversely proportional. If volume will be reduced, then concentration will increase or not? If volume will be reduced, then will the concentration increase or not? Concentration will definitely increase. Now, if volume is reduced to half, concentration will become double. Right? If volume is reduced to half, concentration will become double. Now what will happen in this particular reaction? We will have the concentration of both of them will be doubled. Okay. Now if I solve this, what I will get? A B square, right? And then I will have 8 here. 2 to the 4 to the 8. Now this is my new rate, okay, when the concentration has changed. So new rate is equal to this KAB square is what? It is the initial rate. So the new rate is 8 times of the initial rate, right? So what will be my answer? That is option number C here. Ma'am, the video of chemical kinetics top PYQs, that video is not loading. Okay, Aska, we will check on that. Okay, definitely. So now tell me, anybody is having doubt in question number C? In this first question, answer C. All of you, I want everyone to tell me that this is clear. Then only we are going to move to the next question. If it is clear, please put me a comment that yes. Just write down yes if it is clear to all of you. If you have any doubt, post your doubt right now. Okay, see, this is the very basic concept and we'll be solving questions from this concept only. So yes, now tell me. No ma'am. Pranavi, no ma'am means are you saying that the question you didn't understand? Is this a KCET PYQ by the way? Yes, this is a KCET PYQ of 2021. Okay. Pranavi, what you didn't understand, can you tell me what did you didn't understand? See, the initial rate is given to us, R is equal to K into A into B square. Okay, okay, Pranavi is saying she has understood, fine. Then other students, I can ask Aksha and chill for you, Satish and Ansur, everyone, Somya, Sajina, then we have fourth ball, sorry. Yes. So dear children, please give me your comments and just tell me whether you understood or not. So please reply to that. I'm just moving to the next question. Now the next question is the reaction 2N2O5 gives you 4NO2 plus O2. Initial concentration of N2O5 is 2 moles per liter and after 300 minutes it is reduced to it is 1.4 moles per liter. Okay, the rate of production of NO2, the rate of production of NO2. Can you try this question? Before trying this question, let me tell you the theory that we require behind this. Suppose I have a reaction like this, AA plus BB gives CC. In that case, what is the rate? I have told you in the last class, 1 by A of dA by dt, okay, is equal to minus 1 by B of dB by dt, right, is equal to plus 1 by C dC by dt. Right? So using this equation, you have to, like, this is the theory. If you know this one, then you can solve this question. If you know this one, then you can solve this question. So the reaction is given and what is we have to find out? Rate of formation of NO2, right? And whose data is given to me? N2O5 data is given to me. So what is the relation between N2O5 and NO2? What relation they have? So I can say that rate is equal to minus 1 by 2 of dN2O5 by dt okay, is equal to plus 1 by 4 dNO2 by dt. Okay, so minus 1 by 2 dN2O5 by dt plus 1 by 4 dNO2 by dt. Now this is the formula that we have. Now what is dN2O5 by dt? If you see that what is the concentration change of dN2O5 from 2 moles to 1.4 moles, it has become in how much time? In 300 minutes, right? And we have to calculate dNO2 by dt. So what I'll do, I'll multiply this 4 here. Sorry, I'll multiply this 4 here. So I'll get 4 into, I have multiplied this 4 here, right? Then this 2 is there. Minus of dN2O5 by dt is equal to dNO2 by dt. Right? This is there. Now just substitute the values here. So what I have? Minus 4 by 2. Okay. What is the change in concentration of N2O5? From 2 moles to, it has changed to 1.4, right? So that means 0.6, and I have time is 300. Okay, so now can we solve this and tell me what is the answer? So I have 4 into, this I can write as 6 into 10 to the power of minus 1, and this I can write as 6 into 10 to the power of 2, right? So I'll get here 4 into 10 to the power of minus 3. So what is my option? 4 into 10 to the power of minus 3? Yes, that is option number 3 here. Yes, is this question clear? Any doubt here? Is this question clear? Okay. Now let's move to the next question. Okay. For an elementary reaction 2A plus 3B gives 4C plus D, the rate of appearance of C at time t is 2.8 into 10 to the power of minus 3 mol/liter second inverse. What is the rate of disappearance of B at time t? Just like how we solved the previous question, you have to solve in the same way. Okay, you have to solve this question in the same way. So if we have so we have to solve the rate of appearance of C at time t. Okay, so and the question is asking the rate of disappearance of B. So we have to establish a relation between B and C. So what is rate here? Rate will be equal to minus 1 by 3 dB by dt, okay, will be equal to plus 1 by 4 dC by dt. Now let's substitute the values. The question here is asking us to find out the disappearance of dB by dt, right? So I will have minus dB by dt, okay, is equal to 3 by 4 into dC by dt. Okay, so I will have 3 by 4 into, what is dC by dt? The rate of appearance of C is 2.8 into 10 to the power of minus 3. Okay, so 3 by 4 of this one, so that is equal to this value, which is option number A here. Okay, clear everyone? Yes. No problem, Tara Devi, you can answer from now onwards. Okay, let's do next question. This is very interesting question of 2020-2019, and the similar question was repeated in another year also. Okay, exact question was repeated. So 1 liter of 2 molar CH3COH is mixed with 1 liter of 3 molar C2H5OH to form an ester. The rate of the reaction with respect to the initial rate when each solution is diluted with an equal volume of water will be. If you are diluting it with equal volume, then how much will be the change in the rate? That is what you have to find out. Okay. Yes, now please try this question. Yes, this is very, I'll say this is slightly moderate question, not very easy, moderate to difficult length level question. So how to solve this one? Anyone can tell me how to solve this particular question? Okay, so now see. Okay, now see here. So what is the rate here? We will have rate is equal to concentration of acetic acid and concentration of ethanol, right? Now you have taken one, so what is the rate given here? K into, what is the concentration of CH3COH? 2 molar. And what is the concentration of ethyl alcohol? 3 molar, right? So that will give me 6K, or I can just write R is equal to 6K, something like this. Next, what happens? The rate of the reaction with respect to the initial rate when each solution is diluted with an equal volume of water will be. Okay, so if it is diluted with equal volume of water. Now see what happens here. Now here, what do you mean by this one? That is 2 molar means in 1 liter we have 2 moles, right? Now we have made it suppose 2 liter. In there also it will be 2 moles, right? So what is the new concentration of CH3COH? New concentration of CH3COH. So number of moles is 2, volume is 2, so it will be 1 molar. Similarly, C2H5, what was the concentration? 3m, right? That means what? 1 liter contains 3 moles. Then if I double it, 2 liter will also contain 3 moles, right? So I can write the new concentration of C2H5OH will be equal to 3 moles, number of moles by volume, that is 3 by 2. Okay, 3 by 2. We have got the new concentration. So what is the new rate I have? The new rate will be K into concentration of CH3COOH dash concentration of C2H5OH dash. Now this dash represents the new concentration. Okay, so that is equal to K into CH3COH is 1 molar, right? And this one is 3 by 2 molar. Okay, 1 molar and 3 by 2 molar. So now the question is, what we have to calculate the rate of the reaction with respect to the initial rate. So I have to calculate the final rate and then initial rate. Okay, so R dash value is how much? K into 1, okay, into 3 by 2m. And here what I have? Here I have K into 6m, right? 6 we can cancel, 3 1s are 3 2s are, so 1 by 4, which is equal to 0.25 times. So my answer here will be option number A. Yes, Tara Devi, absolutely correct. Option number A. I hope all of you have understood this question. Next question. If you are having doubt in any part, please just stop me and I'll be explaining. I hope when you are not putting any doubts in the comment section, I'm assuming that the concepts are clear for you. Okay, moving to the 5th question. For the reaction 2SO2 plus O2 gives 2SO3, the rate of disappearance of O2 is there and the rate of appearance of SO3. So this is just a simple question how we have already solved. Yes, Shreks, definitely. Okay. Shanta is saying, ma'am, after 6K, I didn't understand. Okay, Shanta, see here. The question is what it is asking you, the rate of the reaction with respect to the initial rate when each is diluted to equal volume. Means you have added some amount of liquid. You have diluted it equally to both the solutions. Okay. Now, when I say 2 molar concentration, what does that mean? In 1 liter, it is having 2 moles. Now suppose, let us assume that I have doubled this volume. Okay, we can take any amount, but both of them should be done in the same way. So if I double it, 2 liter will be there, in 2 moles will be there. So what is the concentration formula? Number of moles by volume. So we have 2 by 2, that is 1 molar. Now for ethanol, what I did, 3m was the initial concentration. That means in 1 liter it was having 3 moles. Now I doubled it, so it became 2 liter. So now 3 moles is present in 2 liter. So what is the new concentration of ethanol? 3 by 2 molar. Now if I take the R dash, K into this one, so that will be 1 molar into 3 by 2 molar. Now if you take R dash by R, if you just take the ratio, you will get 1.25. Okay, Shanta, I hope you have understood this question. Now let's move to the next question, that is question number 5. Yes, Shanta, please do let me know in the comment section. If you have still doubt, please ask me. Okay, others can solve the next question. So for the reaction 2SO2 plus O2 gives 2SO3, the rate of disappearance of O2 is given. The rate of appearance of SO3. Now see, here we have rate is equal to minus dO2 by dt, okay, is equal to plus 1 by 2 dSO3 by dt. Okay, now what do we have to find here? The rate of appearance of SO3. Means I have to find this dSO3 by dt, okay, is equal to 2 times of dO2 by dt. Okay, that is equal to 2 times of, what is the value of dO2 by dt? 2 into 10 to the power of minus 4. Okay, that is equal to 4 into 10 to the power of minus 4, which is your option number B here. Okay, Shanta has understood, and I hope this question is also clear for everyone. Let's move to the next question. For the reaction half A gives 2B, the rate of disappearance of A is related to the rate of appearance of B by the expression. Again, this is very simple question. Just how we have solved these all previous questions, like that you can do. So what is rate here? See, rate will be equal to minus 1 by 1 by 2. Okay, dA by dt, right, is equal to 1 by 2 of dB by dt. Right, you see in the question on the left hand side we have minus dA by dt, right? So what I can, this, if this goes up, we will have so this is 1 by 2, so this will becomes minus 2 into dA by dt is equal to 1 by 2 dB by dt. Right, now what is dA by dt? Minus dA by dt is equal to, this 2 multiply here, 1 by 4 dB by dt. Right, so what is this 1 by 4 here? Minus dA by dt is equal to 1 by 4 dB by dt, which is your option number A. Okay, students, please do reply your answers in the comment section, okay, so that I can know you are understanding the questions. Moving to the next question, which of the following statement is incorrect? Okay, you have to find the incorrect statement. Molecularity is only applicable for elementary reactions. Yes, that is a correct statement. Okay. Next, the rate law for any reaction cannot be determined experimentally. No, rate law is always determined experimentally. Okay, this is the incorrect statement. Rate law for any reaction can be determined experimentally. So that is why option number B is the incorrect statement. Bimolecular reactions involve the simultaneous collision between two species. Yes, that is the correct statement. Complex reactions have fraction order. That is also the correct statement. Okay, so B is the incorrect statement here. Next, for a chemical reaction Ma gives Xb, the rate law is R is equal to Ka square. If the concentration of A is double, then the rate will be. This is also very simple question. Can you people try here? See, rate will be equal to, all of you can try by your own now, rate is equal to Ka square. Now if the concentration of A is doubled, so I'll do R dash is equal to K into 2A square, that will become 4Ka square R dash. Now if I divide R dash by R, okay, so what I will get here, 4Ka square divided by Ka square. Right, so I'll have 4 times. So it has increased by 4 times, right? The rate of the reaction has increased by 4 times, that is quadrupled. Yes, absolutely correct, children. Now let's move to the next question. 3A gives you 2B, the rate of the reaction dB by dt is equal to. So if you have this equation, see, how will you write? Rate is equal to minus 1 by 3, just let me write once again. Yes, so rate is equal to minus 1 by 3 dA by dt, okay, is equal to 1 by 2 dB by dt. Okay, so now what I can solve here, dB by dt is equal to minus 2 by 3 dA by dt. Very simple, right? So what is d by dt? Minus 2 by 3 dA by dt, which is option number B here. Yes, Santa, absolutely correct here. Next question. This question is very similar to what we have already solved. You can see 100 centimeter cube of 1m CH3COH was mixed with 100 centimeter cube of 2m CH3OH to form an ester. The change in the initial rate if each of the solution is diluted with equal volume. So just now we have solved this question. Whatever, when you dilute it with equal volume, the rate will decrease or increase by 0.25 times. So I have already solved the similar question. So this question, yes, Shanta, absolutely correct. Just like the previous question, we can solve this question. So let's not waste our time here. But yes, the similar question I have explained you already. Now let's move to the question on rate constant. In which of the following reactions the rate constant has the unit of mole liter inverse second inverse? Now what is the general unit of K? It is mole 1 minus n liter n minus 1 second inverse, right? Now if you see here, what is the value of 1 minus n is given as 1, right? So n value will be 0 here, right? So what is this order of reaction? So according to the rate constant, I can know that it is a zero order reaction. Now you have to know the examples of zero order reaction. If you know the examples, very easy question. So decomposition, all the surface catalyzed reactions are your zeroth order reactions. So option number D is the correct answer. Next, the rate of the reaction is given here, given by this particular. If the concentration is expressed in mole liter inverse, the unit of K is. So you can see this is a second order reaction. N is what here? 2. And just now I have written mole, unit of K is mole 1 minus n liter n minus 1 second inverse. So here I will get mole inverse, then liter second inverse, okay? Mole inverse, liter second inverse, so option number A here. Next, for a reaction A plus 2B gives you product when concentration of B alone is increased, the half-life remains the same. Concentration of B alone is increased, the half-life remains the same. Means once the half-life is independent of the concentration. So the T half for a first order reaction is what? 0.693 by K, right? That means for this particular, means for reaction B, the order, so let us first assume that the reaction has to be in this way. Then we need to assume, or we have to find the value of X and Y. So if I see that the half-life for B, the half-life is independent of the concentration, that means with respect to B, it is a first order reaction. So I have figured out that Y is equal to 1. If the concentration of A alone is double, the rate remains the same. The rate remains the same. Means even if you change the concentration of A, there is no change in the rate of the reaction. That is because this must be a zeroth order reaction. So X must be 0. So what is the overall order of the reaction? You have X plus Y. X plus Y is 0 plus 1 is equal to 1. So for a first order reaction, what is the unit? Second inverse. How will you find? Ma'am, we have this formula, moles 1 minus n liter n minus 1 second inverse. Now let me substitute 1 here. So this will become 0, this will become 0. Only second inverse will remain. So option number A is correct. Yes, Shanta, absolutely correct. Next, the value of the rate constant of pseudo first order reaction. This is the bang on question. Means this much tricky question, every child will do mistake here, but if you have attended this session, if you have listened to me, then you will be saved in such question. I'm guaranteeing you. So the value of the rate constant of a pseudo first order reaction, all of you have studied pseudo first order reaction, where one of the reactant is taken in excess and the rate only depends on one concentration and it behaves as a first order reaction. So depends only on the temperature, depends on the concentration of reactants in a small amount, then depends on the concentration of the reactants present in excess, is independent of the concentration of the reactants. Now see, here the question is asked about rate constant, okay? Rate constant is K value, and this value always depends on temperature. Okay, so here the correct answer is option number A, depends only on temperature. Okay, yes, Santa, absolutely correct. It is not zero order, dear. It is first order. It is first order. I think you are asking for the previous one. Okay. Next is from the integrated rate law question. So if the rate constant of a first order reaction is K, the time required for completion of 99% of the reaction is. Very simple reaction. What is the equation for the first order? 2.303 by T log of A naught by A, right? So I will have here, I have to find the value of T. So 2.303 by K log of A naught value is, I have like 100 for example. Okay, and 99% is completed. That means 1% will be left. So it is 10 to the power of 2. 2 will come here. So we'll have 4.606 by K. Okay, so that will be option number A here. Okay, Shanta, it will be option number A. Please check the calculation. Next, the time required for 60% completion of first order reaction is 50 minutes. Then the time required for 93.6% completion of the reaction is. Okay, now see, for 60% it is given, right? For 60% it is given. So how will you calculate? K equal to 2.303 by 50, okay, log of 100 by 40, means for 60% is given, so 40% will be remaining. So log 4 is 0.6 and log 10 is 1, so 1 minus 0.6 will be something around 0.4. So I will get 2.303 by 50 into 0.4. Okay, just I am doing a rough calculation. Okay, you can see the options are very far away from each other, so you can make some rough calculation here. This is the value of K. Next, the question is asking to calculate the time required for 93.6%. So what will be the time required here? See, 2.303 by K log of 100 by, if I am having 93.6% is there, right? 100 minus 93.6. So I have 10 minus 6, 4, 9 minus 3, 6. So I have this one, that is 6.4 here, right? 100 by 6.4. Right, now what I'll do, in this place of K I'll substitute everything. So 2.303 was the value of K. 2.303 into 0.4, I'll write 4 by 10 because I'm very much afraid of decimals. Then into 50 I have, okay. Then log of this, can I write 1000 by 64, right? 1000 by 64 I can write log. So let's solve this one now. Okay, now see, how can I write this one? I'll solve this. How to solve log, you people keep asking, right? So let me solve and show you this particular question. Okay, see, you have log 1000 by 64. Log 1000, can I write 10 to the power of 3 cube, and 64 can I write 4 cube, right? 4 4s are 16, 16 4s are 64. So that is equal to log of 10 by 4 cube, right? This 3 can come here, 3 of log 10 by 4, right? Then you have 3 here again. Log 10 is 1 and this one is how much? Log 4 is 0.6, right? So I have how much? 3 into 0.4 here, right? So that value I will get here. So I will write 2.303 by 2.303 into 10 by 4 into 50, and here I have log into 50 into 3 0.4, that I'll write as again 4 by 10. So this 4 got cancelled, this got cancelled, this got cancelled, this got cancelled. So 50 into 3, I have just 150 minutes. So that is option number C here. Okay, clear? Okay, next question. Okay, A gives you P plus Q plus R, follows first order kinetics with a half-life of 69.3 seconds. Okay, so what is the half-life given to me? T half is 69.3 seconds. Okay, starting from the gas A enclosed in a container at 500 degrees Celsius and a pressure of 0.4 atm, the total pressure of the system after 230 seconds will be. So this is from your gaseous reaction. So let us see. You have A gives you P plus Q plus R, right? Now it is saying that the starting from the okay, first from here let me get the value of K. K is what? 0.693 by T half, that is 69.3. So how can I solve this? 693 into 10 to the power of minus 3 by 693 into 10 to the power of minus 1. This will get cancelled, this will go up. So it is 10 to the power of minus 2. K value is 10 to the power of minus 2. Now what we have, starting from the gas A enclosed in a container at 500 degrees Celsius and a pressure of 0.4 atm. Okay, so initial pressure was 0.4 atm. Okay, then we have 0, 0, 0. Now suppose X amount has reacted, so here XX will form, right? Now what is the total pressure of the system after 230 seconds will be? Okay, so let's imagine that the total pressure will be 0.4 minus X plus X and plus X, right? So I will have, okay, one more X is there. So this 2 will cancel, so it will be 0.4 plus 2X. This is the total pressure, right? So first of all, I have to find out this value of x here. So how will you calculate? See, we have k is equal to 2.303 by t log of initial concentration of A is 0.4, final concentration of A is 0.4 minus x. Now from this I'll get the value of x. What is the value of k here? I have got 10 to the power of minus 2, okay, is equal to 2.303. Now what is the time given to me? Time is also 230 seconds, okay. So for easy calculation, let us make this also 2.30, okay. That is equal to, then you have this log of 0.4 by 0.4 minus x. Now here what will happen, this can be, if you see, I will cancel everything, I'll get here 1, okay. So if I take antilog, I'll get 10 is equal to 0.4 by 0.4 minus x. Now multiply 10 on this side, so you will get 4 minus 10x, okay. So if I multiply 4 minus 10x is equal to 0.4. So what will be this one? 3.6 is equal to 10x, or I can solve x is equal to 0.36. Okay, now what is the total pressure? I have to substitute x here. So 0.4 plus 2 into 0.36. So that will be 0.72. So 0.4 plus 0.72. Okay, so that will be giving me 1.12 something, which is option number D here. Okay, next question number 18. From the reaction PCl5 gives you PCl3 plus Cl2, the rate and rate constants are given. The molar concentration of PCl5 at that instant. This is also very simple. See, you have this formula, rate is equal to K into PCl5, right? And the values that is given, rate and rate constant is given. Rate is 1.02 into 10 to the power of minus 4, and rate constant is 3.4 into 10 to the power of minus 5, and this is the concentration. This value I have to calculate. So 1.02 by 3.4 into 10 to the power of minus 4 divided by 10 to the power minus 5. This goes up. Okay, now I'll get 10 by 10.2 divided by 3.4. So if I solve, it will be somewhere around 3. So I'll get 3, which is my option number B here. Okay, clear? Next question. A first order reaction is half completed in 45 minutes. How long it take for 99.9%? This question is also very tricky question. You can solve it in fraction of seconds if you know this one formula. T 99.9% is 10 times of T 50%, right? So we have how much? 50% time is 45 minutes. So T 99 will be 10 into 45 minutes, right? That is equal to 450 minutes. Now options are in hours. Divide by 60. So you will get 67.5. That is option number D here. Next, the half-life period of a first order reaction is 60 minutes. What percentage will be left after 240 minutes? Okay, so let us start with, for example, 100% is there. Okay, so the half-life is how much? 60 minutes. After 60 it will become 50, then again after 60 it will become 25, then again after 60 it will become 12.5, after again 60 minutes it will become 6.25, right? So after, you can see how much time we have covered here. See, 60, 60, 60, 60, we have covered 240 minutes. So with that, how much percent will be left? Option number A, that is 6.25%. Okay, so yes students, so these were the top 20 questions in the last 10 years that have been covered. Okay, so I hope you have understood these questions. If you have any doubt, please put down in the comment section. I'll definitely address to that. And yes, thank you so much for coming live and just sharing your inputs, output, everything. So thank you so much, all the best. And if you have any doubts, do not forget to pin in, put your comments in the comment section. We will be addressing you. Okay, thank you and bye bye, take care.